Record. Webb just discovered the oldest star clusters. The launch of NASA's James Webb Space Telescope, collaboration with the European Space Agency and the Canadian Space Agency, marks the beginning of a new era in astronomy. On July 12, 2022, at 10:30 a.m. EDT, at NASA's Goddard Space Flight Center in Greenbelt, Maryland, the telescope's first full-color photos and spectroscopic data were made public. We will have a look at the official launch of Webb's general science activities as well as the observatory's initial collection of full-color scientific images and spectra coincide with the targets. An international committee that selected them was made up of representatives from NASA, ESA, CSA, and the Space Telescope Science Institute. So let's have a look on what Webb just discovered. The information in these pictures relates to the early cosmos, star birth and death, galaxy collisions, and exoplanet atmospheres. Moreover, they're stunning. In contrast to earlier telescopes, this one lacks the smudgy, pastel quality. As light is being painted, the clarity and sharpness of the painting may cause you to think of Vermeer. The deepest and brightest infrared image of the outer reaches of the universe has yet been captured by NASA's James Webb Space Telescope, Galaxy Clusters SMACS 0723, which is part of Webb's First Deep Field, is teeming with hundreds of galaxies, including some of the most faint things yet seen in infrared light. Webb's image represents a minute fragment of the huge cosmos, approximately the size of a grain of sand held out at arm's length. This galaxy's cluster's total mass serves as a gravitational lens, enlarging galaxies that are farther away, including some that were discovered when the universe was only a few billion years old. This infrared deep field was captured by Webb's near-infrared camera. It is a composite constructed from photos collected at various wavelengths over the course of 12.5 hours, surpassing the deepest fields captured by the Hubble Space Telescope, which took weeks to complete. This is just the start, though. Longer exposures will continue to be taken with Webb by researchers and showing more of the enormous universe. The galaxy cluster SMACS 0723 is visible in this image as it would have been 4.6 billion years ago, with a great number of other galaxies in front of and behind the cluster. As experts dive deeper into Webb's data, much more about this cluster will become clear. The mid-infrared instrument on Webb, known as MIRI, also captured images of this field. Billions of years have passed before the light from these galaxies reached us. Viewing the youngest galaxies in this universe, we are looking back in time to within a billion years of the Big Bang. Webb was designed to observe infrared wavelengths, which were produced as a result of the universe's expansion stretching the light. Soon, more information about the galaxy's masses, ages, histories, and compositions will be known to researchers. In addition to taking photos, two of Webb's instruments also gathered spectra, which are data points that reveal an object's physical and chemical properties and will help specialists in this field understand more specifics about distant galaxies. A brand new technique employed for the first time in space. Webb's near-infrared spectrograph observed 48 distant galaxies at the same time and returned comprehensive information about each. According to the findings, one galaxy's light traveled for 13.1 billion years before being caught by Webb's mirrors. Webb's near-infrared spectrograph data also show how finely detailed galaxy spectra will be with Webb observations. Hubble has already captured a picture of the SMACS 0723. Although the photos look fairly similar, the JWST image is richer and provides an unprecedented perspective of thousands of distant galaxies. The new space, which has a better light gathering capability, was able to capture images of numerous distant galaxies in the same region, including some of the most faintly lighted objects ever spotted in the infrared. Some of the galaxies in the images are depicted as they were more than 13 billion years ago, when the cosmos was still extremely young. Webb has received a number of cutting-edge technological developments. Included in these is a main mirror consisting of 18 different parts that unfold and assume their final configuration after launch. Exceptionally light beryllium is used to make the mirrors. A 5-layer sun shield the size of a tennis court that attenuates heat from the sun more than 1,000,000 times in Webb's most notable feature. The spectrometer and cameras, which make up the telescope's 4 instruments, contain detectors that can capture incredibly low signals. Up to 100 objects can be discovered simultaneously by one device, which features customizable microshutters. The mid-infrared detectors of another instrument on Webb are likewise cooled to an extremely low 7 kelvins so they can function. The James Webb Space Telescope provided a magnificent variety of galaxies in that photograph, which was its first deep field view and a group of Canadian scientists has focused on a galaxy that is 9 billion light-years away from Earth and is known as the Sparkler Galaxy, because the compact objects that surround it look like tiny, shimmering yellow-red dots. The galaxy itself is remarkable due to its strange stretched appearance, but the nearby objects that give rise to the term are of great scientific significance, as they may be the farthest globular clusters of stars yet discovered by scientists. Globular clusters are collections of ancient stars that have existed since the beginning of a galaxy. As a result, they may contain knowledge about the early stages of galactic formation, growth, and evolution. The Canadian NIRISS Unbiased Cluster Survey team examined the 12 compact objects that surrounded the Sparkler Galaxy and discovered that 5 of them are in fact globular clusters. Furthermore, these might be some of the oldest globular clusters ever discovered, possibly existing at the moment the cosmos first started to form stars. About 150 globular clusters are thought to be present in the Milky Way, although their ages are unknown. According to Mawla, while most things in our galaxy can be age-dated rather steadily, this isn't the case for truly ancient objects. Mawla also remarked that these objects appear older when seen up close and are therefore older in time. When the cluster was much younger and the universe was only 4.5 billion years old, it was much simpler to date distant clusters like the Sparkler Galaxy, which astronomers say as being 9 billion years ago. How much the SMACS 0723 galaxy cluster, which acts as a lens for the Sparkler Galaxy, is magnifying it, is one of the unanswered questions. I remarked, the magnification of the Sparkler Galaxy and its environs is not as well constrained as we'd want. So, one of the things we would want to do is to construct a better magnification model so that we can determine if it's enlarged by a factor of 10 or by a factor of 100, says the researcher. The research team's theory is that these sparkles are either older globular clusters or young, actively growing star clusters that formed 3 billion years after the Big Bang at the height of star formation. Globular clusters are old collections of stars that date back to the creation of a galaxy and reveal details about the early phases of its growth and expansion. The researchers found that 5 of these compact objects are among the oldest known globular clusters after performing an initial investigation on 12 of these compact objects. Globular clusters, which include tens of thousands to millions of stars, are stable, firmly bound clusters. They are connected to all different kinds of galaxies. Globular clusters are strongly gravitationally bound and often larger than open clusters. A star cluster is one of the 2 types of stellar assemblages that are bound together by the gravitational pull of their individual members, who are linked together physically by a shared origin. Open clusters are also known as galactic clusters, and globular clusters are the 2 forms. Open clusters typically have an asymmetrical configuration of several dozen to hundreds of stars. Contrarily, globular clusters are ancient systems with tens of thousands to a few hundred thousands stars packed together closely together in a symmetrical, nearly spherical structure. Also identified are associations, which are collections of a few dozen to several hundred stars of familiar and similar size and origin, but with a lower density in space than the surrounding field. By the beginning of the 21st century, the Milky Way galaxy included more than 150 globular clusters. The majority are widely dispersed throughout the galactic plane, while roughly a third are clustered as satellite systems in the dense star fields of Sagittarius and Scorpio, close to the galactic center. The apparent diameters of individual cluster masses range from 1 degree for Omega Centauri down to knots of 1 minute of arc, and their linear diameters can be several hundred light-years. Each cluster mass contains up to 1 million suns. In a cluster like M3, 90% of the light is contained within a 100 light-year diameter, while star counts and research on the member stars of RR Lyrae, whose intrinsic brightness varies periodically within well-known bounds, include a wider 325 light-year diameter. The concentration of stars in the centers of the clusters varies significantly between them. Some of them, like Omega Centauri, are clearly elliptical despite the fact that most of them appear round and are most likely spherical. M19, with its most main axis about doubling that of its minor axis, is the most elliptical cluster. The Milky Way galaxy, a massive star system of which the Earth is a minuscule part, has 2 satellite galaxies, one of which is the Magellanic Cloud. The Magellanic Clouds are a pair of irregular galaxies that are 22 degrees apart and share a gaseous envelope. They are located close to the south celestial pole. The small Magellanic Cloud, which is less than 2 degrees across, and the large Magellanic Cloud, which is around 5 degrees across, are the 2 distinct luminous patches. The importance of the discovery lies in the fact that these globular clusters are more than 13 billion years old. They are one of the oldest clusters that we have ever found to date. Furthermore, their color is consistent with stars originating in the first 500 million years of the Big Bang. That's the same time astronomers believe the first galaxies started forming. If these ages are confirmed, the clusters appear contemporary to the large-scale reionization of the intergalactic medium, hinting at a deep connection between globular and cluster formation in initial phases of the galaxy assembly. Gravitational lensing is one of the most important physical phenomena for the astronomers studying the distant universe. It magnifies and exposes those objects and regions of the cosmos that worldwide remain out of sight, and no one knows how much deeper Webb will take us. So, what are your thoughts on these amazing discoveries?